Hello, I'm Lee from Data Harvest. Today I'm going to show you how the wireless force sensor works. I'm going to do a couple of experiments because the force sensor has a plus or minus 100 Newton sensor built in, as well as an accelerometer and a gyroscope as well. But as you can see, we've already got it set up just here to work for the SHM experiment, which is a classic one that people like to do with the force sensor. So screw thread at the top here, so you can connect it to bosses, through the boss, on the clamp, on the retort stands. A nice, easy, convenient way to do this. Any spring within reason, a reasonably flexible spring that you already have in school will work quite happily as well. Now I've got 500 grams on here. You do need at least 300 to 400 grams to get a nice SHM experiment with this. But a little tip, got some blue tack in here. Otherwise, sometimes it will just move around on the hook, and that can cause a bit of a spiking on your data. So a little bit of blue tack solves that problem a treat. So I'm now just going to hold down the sensor on here, and it's going to now light up. So it's now got flashing, so it's got Bluetooth. Now, all our wireless sensors have USB and Bluetooth built in as standard. So if you're using Chromebooks, Apple Macs or Windows PC, you can use Bluetooth or USB. Now, if you're using Android devices or iOS devices, then you can do Bluetooth quite happily on there as well. So on our software, EasySense2 software, which is a free download from all those 5 app stores, go and click on device on the top left-hand corner. Now you see it says force and a 6-digit number. Now I've got 2 force sensors here, so for this video I don't have to undo that one when I'm going to show you some acceleration experiments towards the end of the video. But on the front, if you have multiple force sensors in the classroom, they'll all say force, but afterwards is a unique 6-digit number for that force sensor. So it doesn't matter if you have multiples in the classroom at once. So if I go and click connect, so it's now going to connect to the software here. You can see the acceleration and the gyroscope built in as well, but we only want the force sensor for now. Go and click on start. Now lots of our sensors, you can also tear them. Now because I've got a mass on here, it's bouncing very slightly, so let's just stop that bouncing as much as we can. There you go. So we'll stop that like that. So on the right hand side here, it always gives you live data. So I can click on here, click set tear, and that will now take it back to 0. Now, if you then do other things through the experiment and you're not sure if you've actually torn the data or not, you can see you have a little T on the left-hand side, which means you have torn the data. Okay, so I can now click start. It will be at 0, but if I slightly bounce this, we have the data on the screen. Now, we don't want too much data on the screen, so we'll just click stop. So we've got that down. Now, if I'd left it, you could have had dampening and you would have seen it generally over time go back down to 0. That's another experiment, and it's set up exactly the same way as we've got SHM here as well. So now I can go to calculate. You don't have to do this now. SHM, it's showing there. You can have it as dampening, as I said, but I'm actually going to derive the velocity data from the Newton's data and then get the acceleration data from the velocity data. But even though that looks like it's really, really nice and smooth, you can see this moving around a little bit on here. So there is some very little bit of spiking that you can't see. So I'm just going to smooth the data just once or twice to start off with. So that's on the screen there. I can now go to calculate. Now I'm just going to abbreviate velocity to VEL. The units is m/s. Now what we need to do here is use the formula dx divided by dt. There you go. Derive the data from the force data and just save this. And that is now the velocity data on the screen. Now, a couple of things I could have done. Do we really want this data on the screen here? If you think, well, actually, no, I don't. We could have selected the data beforehand or during, like I'm going to now. I can actually say, go to select data from here to about here. That's fine. Use select data, just gets that off the screen there as well. Now I'm going to go to calculate again. I'm now going to derive my acceleration, acceleration from my velocity data. So instead of typing the whole word acceleration again, I'll just do ACC for this. Put the units in, which is m/s/s. Again, use the same formula, dx divided by dt. I will now want to derive from the velocity. That's an important part. You need to make sure you're deriving now the acceleration from the velocity, otherwise you just get the same reading again. So we go and click on velocity just there, click save, and you'll see that's now appeared on the screen. Go to tools on the top left-hand corner, go to values, And you'll see we've now got the opposite there. Actually, that one should be a better one just there. There you go, perfect. So you see the acceleration data down the bottom, the force data, and then you've got the accelerated data there, so you can see it's opposite. All right. Some other extension activities for this is, I'm just going to turn this one on now. So again, just turn it, hold it for 2 seconds. It's now broadcasting Bluetooth. I'm going to go to File and New Lab. Go back to Graph. Don't want to save that old data. Go to Devices. Now I'm going to turn off the 7801 and turn on the 840. So we can see I'm going to turn the acceleration on now, turn force off. So I'm just going to show you how easy it is just to show G with the force sensor. So turn this off. Just going to have X, accelerometer working for X. Now just going to tear this just so we've got it finished. Here we go. On the top left-hand corner of the graph here, now again, lots of videos showing you how to use all of the software. That's why I'm not concentrating too much how to use the software. There's lots of videos already online for that. If I go and click the numerical reading down the bottom and now click Start, I've got a lovely big reading on there. But if I now use the X-axis, it's now showing 9.84 G. So that's a really nice one to show on the screen here. But what's really cool as well, if I click Stop, show this as line data. So we've got this on here. So that's what it was actually recording behind the scenes. It's always storing the data. Actually going to go to File and New. Click on New Lab. Go back to Graph again. Click it to start. So it's now showing 9.8. If I pick this up and now drop it, watch the graph. You see it's gone down to 0. So therefore it was then fallen at 9.81 meters per second. So it's just a really nice one to do that. I get 2 students to do it. It works a treat. Get them about a meter apart, one to drop, one to catch, then obviously you'll have it longer on the screen. But what you can do to emphasize that a little bit more is you can use the local tools. So when you've got the graphs open, we class these as local tools, the top ones as the global tools. So if I now go and click on zoom in, I can zoom in to this bit just here, and that just shows how it was down at 0 there as well, because we could go to Tools, go to Values, and show that on the screen there as well. Now there's lots more videos on our website. If you go down to the drop-down menu on data-harvest.co.uk, the drop-down menu teaching, you'll see the Secondary Academy there. There's a Primary Academy as well. If you click on the Secondary Academy, it will take you to our website, our YouTube website, and you have 3 choices. We've got how all the Bluetooth sensors work, how they work with the experiments, and then how the EasySense 2 software also works as well. Now you need any more help, support, questions, please go to the website or drop us an email on sales@data-harvest.co.uk. Thank you very much.